All right, I'm Steve Sogo. I teach chemistry at Laguna Beach High School, and I'm here to describe our project. Our project was to create a synthetic antivenom. The traditional method of making antivenom is to inject venom into a horse or a sheep, and then to harvest the blood of that animal, which has significant quantities of antibodies in it. So it's essentially using the animal as a factory to produce antivenom. In our case, we wanted to build an antivenom out of plastics. And the idea is that plastics are a 21st century commodity. I really think the idea of injecting a horse is very medieval, and we should be able to do better in the 21st century. So the idea was to use molecular imprinting. The idea has been around for probably 30 years. And it's to create a polymer in the presence of a template molecule. So here I'm demonstrating the idea. If this is my template molecule, which in our case would be a snake toxin, we build the polymer in solution, adding monomers to create this sort of structure, which clearly is meant to grab onto the toxin. And then we can dialyze out the toxin, and we're left with this. And this would be our molecularly imprinted polymer, ready to grab onto its target molecule. In real life, what that means is we take these various substituted acrylamides, these are our monomers, and we can polymerize these using ammonium persulfate as a free radical initiator. And we produce this, which is a nice opalescent suspension of nanoparticles. This is our synthetic antivenom. We've had these samples for a couple of years now, and although I haven't tested recently, my guess is these have the same activity that they had 2 years ago. The real big advantage we have here is this requires no refrigeration, should have an indefinite shelf life, unlike the antibodies you get from a horse or a sheep that need refrigeration and have a very limited shelf life. So this is our idea. This can save lives.
I think the main way that an ACR education differs from that of a traditional education is that it allows you to explore on your own and learn more by doing and failing in your own trials and tribulations, rather than just sitting and being instructed by someone who's already gone through what you're supposed to go through.
Yeah, well, it seems like everything that we do is actually relevant to the world rather than just learning basics that everyone else is learning. We actually get to do real research that makes a difference.
Yeah, it feels like what you're doing is actually going to be used and is worthwhile.
Most classes, they prepare you for a test. You know, they're preparing you at the end for this one test, and so you learn everything a specific way, but you don't really know how to use the knowledge that you gain. Whereas in this class, you learn how to explore on your own and how to teach yourself things. And this class is often compared to like AP classes, like AP Chem, and the big difference is that, you know, they're all getting ready for that one AP test so they can get their college credit. But at the end, you know, the knowledge that we gain from this class is so much more useful in everyday life than any other knowledge from any other class we ever take.
I think the biggest surprises, for me at least, were just how quickly we were thrust into projects and how easy it was to fail in those projects. Like, we're just used to getting an assignment, getting it done, turning it in. But here it's like we have this assignment that no one's ever done before, and we have to come up with our own ways to solve it, figure it out, different methods on what we're supposed to be doing at all times. And it was really surprising to just sit down and just have to solve a problem that no one's ever looked at before.
I thought it was kind of weird, you know, walking into class. This was like the second or third day, and he gave us our groups. Brock was in my group at the time, and we just kind of sat there, and he said, all right, you know, the next 6 weeks, your goal is to extract the most pure sample of caffeine you can from Diet Coke.
That's it. It's
and,
over.
Yeah, there was nothing else he gave us. And, you know, as a high school student, we're sitting there used to getting this huge lab protocol with procedure and everything, and
Step-by-step instruction.
Yeah.
And he just says, you know, get me caffeine. And I think everyone was a little.
Yeah, exactly.
We're all
Scared,
walking
flustered.
around like, what? What
All
are
on
you
the
doing?
phones.
What are you doing?
And
But I mean, that's really the scientific method is you have to explore what other people have done before you and other techniques to try to make it fit your own application, your own project. When before it's like we were just told and we're just following orders. In this, we actually have to look into what other people have done and explore different chemistry techniques and all sorts of very interesting and useful things. One of my most memorable moments in this class is usually when the culmination of your experiment leads to your final analyzation, like whether you did it right or not. And we use these extremely like accurate machines to analyze whether what we have been trying to create or trying to accomplish has actually worked. And one very specific instance is at the beginning of the year, or actually more recently in my project, when we were trying to create this molecule the entire year. Whole different types of methods, and there's so much failure and so many different trials and things that we were trying to put together. And eventually we get to go to this research institution, UC Irvine, right over here, and use their NMR machine, which is this crazy, powerful analytical tool, and we finally see that what we have been trying to do has succeeded, and that there's little lines on the screens that mean nothing to anyone else is just pure joy and satisfaction.
I think kind of really memorable moments are just breakthroughs because they're, you know, a lot harder to come by than at least I ever thought would happen, you know. And so, like at first in the caffeine lab again, you know, when we finally had that powder of caffeine, I mean, we had nothing. There was very, very little caffeine. But just seeing any white powder made me unbelievably happy. I mean, it's just stuff like that I don't know. It's weird.
Yeah, like we've been working for so long trying to oxidize rosiglitazone, and when we're running HPLCs of our oxidized reactions, just seeing that one tiny little blip that means absolutely nothing to anyone else, just seeing that one blip, we're like high-fiving each other, jumping up and down. It's just so rewarding, and all the hard work has paid off.
I plan on pursuing a career in science. Not necessarily intense chemistry, but mechanical engineering, which does include much of the same thinking processes and fundamentals laid down by this class, and definitely stimulates the same part of the brain as everything that we have done in here. So this class has been extremely instrumental in my decision to pursue that.
Yeah, I'm pretty similar actually. So I have been applying to college as a mechanical engineer, and I don't know, starting to take this class, all of a sudden I started thinking, is there any way I can get chemistry into it, you know?
Materials.
And so I started looking into chemical engineering instead of mechanical engineering, and I think I finally decided that I want to either minor or double major with chemistry, because I want to be able to incorporate the chemistry into my mechanical engineering degree, because I really do enjoy the research.
Yeah.
I mean, I don't know, and so I'm gonna try when I get out to Montana to, you know, get into a research lab and do some chemistry work.
Yeah, I plan on being a chemical engineer, but focusing in environmental technologies, because I really want to work with water pollution and researching different processes to help solve that problem. But this class has just reaffirmed my interest in chemistry and research, because before this class I knew I wanted to do something with chemistry, but I didn't really know yet. And although research can be tedious and hard, but it's definitely rewarding, and it's so interesting because it's something that it's like a mystery that you're just trying to solve, and it's just all those steps and breakthroughs that you make along the way are just so rewarding and interesting, and it's just motivated me to pursue it even more.